Hey everyone, I am Miss Hu, your physics teacher. In this video, we're going to go through some tips on how to answer the questions in the IGCSE Physics Paper for Theory. Now, this video was taken early 2025, so you'll find that the past year questions, which I have included as examples in this video, only goes up to late 2024. If you're watching this video at a later date, you should find that the tips will still apply. If there are any updates that I feel you need to know, I will make a video in time for you to prepare for your examinations. Now, before we jump into those tips, let's understand a little bit more about what Paper 4 is. Let's move my face out of the way here. Paper 4 is for students who are taking the extended syllabus. If you're planning to take core, that would be Paper 3. Generally, the tips should still apply, but if you'd like me to make tips on how to answer Paper 3, please leave a request in a comment below. So in terms of Paper 4, what is it? Paper 4 consists of about 10 to 11 major questions in total, and each question could vary in terms of the value of marks. However, no matter how many questions there are within this paper, the total marks of all the questions will come up to exactly 80 marks. You would need to answer this paper within 1 hour and 15 minutes. The score you get in this paper will contribute to 50% of your entire grade. The kind of questions that you will come across in this paper are short answer and structured questions. So that means the questions that you'll come across in this paper are open-ended. You'll need to come up with the answers yourself. Now, as of this video's date, there are 6 units in your syllabus, and questions will be tested from all 6 units. Now, before we go into those tips, let's just go through some general advice about what you should or shouldn't do. Now, first of all, let's talk about your stationery set, which you will need to bring in. You can only use black or blue pens for writing your answers. You must also make sure you have a pencil, preferably HB, because all drawings must be in pencil. Now, the drawings that you may have to do in your paper may include graphs, diagrams, and even lines, such as connecting lines or lines for a table. Anything which you need to draw must be in pencil. You'll also need to bring an eraser just in case you need to rub off any mistakes that you made with the pencil. Make sure you also bring a short or long ruler, because any lines you draw should be drawn with the assistance of a ruler. Remember to also bring a scientific calculator, a protractor, and all of your stationery must be in a clear, transparent case. Now, do not bring the following because you are not allowed to use any colored pens other than black or blue. So don't try to stand out from the crowd by bringing an orange or green or pink pen. It will be stated very clearly on the cover of your examination paper that you can only use black or blue. And in fact, all the practice questions you've been doing up to now in school or at home should have been in black or blue only. You are also not allowed to use erasable ink. Now, I know that in the stationery stores, you can now quite easily buy a pen which comes with an eraser at the back to erase the ink on the pen it comes with. This is not allowed, and in fact, it puts yourself at a great disadvantage. Why? Because the problem with erasable ink is not that it's erasable, but rather the ink fades with time. I have seen some papers where students have written the answers with erasable ink, and in less than 1 week the ink had completely faded, so much so that the paper looks completely blank. So if you were to use that kind of ink for your exam paper, you gotta remember that by the time it gets to the examiner, it could be more than 1 week later. All the examiner is seeing is a blank piece of paper, and it doesn't even have your name or code on it, which means that effectively it is as if you have never sat for the paper, even though you turned up in the exam hall and spent that hour and 15 minutes writing a lot of things. And yes, that means you'll get a 0 for this paper. So do not take the chance, do not use erasable ink. Now, you're not allowed to use a highlighter in your examination paper, and you also cannot use any correction tape or fluid. For the highlighter and correction tape or fluid, this is also already mentioned in the instructions on the cover of the examination paper. If you're thinking, how do we make a correction if you made a mistake in your answers? All you do is you take your pen, just put a line through the answer you have made, and rewrite your answer at the side. Look, the examiner is quite smart. They're going to be able to see where your actual answer is. Now, all of these refer to the stationery you are not allowed to use. So it's not that you're banned from bringing them into the exam hall, but there's no point bringing them in because you can't use them anyway. So don't pack this in your list. However, there are some things which are banned outright. If you bring them into the hall, they will be confiscated, or if they're found on you during the exam, you could be written up as cheating. So make sure you don't bring in any of these following. You cannot bring in your calculator cover or calculator case. Why? Because some calculator cases have equations written on them. You are not allowed to bring in an opaque stationery case as well. The reason is very obvious. Some students may try to smuggle in crib sheets and try to hide them in that case. A crib sheet basically is a small piece of paper with information written on them to help them answer the questions in an examination. You're also not allowed to bring in any devices into the examination hall with you, and this includes phones, tablets, laptops, even smartwatches. Anything else besides this list, don't bring in. Now, some suggestions on what you should do before the examination. Make sure you get enough sleep. I've had students in the past who tried to pull an all-nighter by staying up studying, and what happened was they got so tired. One, they actually end up being late for the examination. Now remember, if you start late, they're not going to give you any additional time. If you come in late, depending on how late you are and whether the chief invigilator wants to let you in, you will have to finish exactly on time with the rest. So for example, if you come in 15 minutes late, you will have 15 minutes less to answer the questions in the paper. Now, even if you're there on time, if you're too tired from pulling an all-nighter, you're not going to be able to focus and think of the correct answers. I've even had students who fell asleep during the examination because they were way too tired. So do not do the silly thing by trying to stay up all night. Make sure you get enough sleep. Be early, not on time, because when you're there early, you're able to calm yourself down, settle your mind, and prepare mentally to do well for the exam. Sometimes when you're just in time, you might still be in a bit of a panic, and that's not a good start for your examination. Before you even leave the house, make sure you have everything you need for the exam. Make sure you have the complete stationery set as mentioned in the previous slide. So all your pens, your sharp HB pencil, ruler, eraser, protractor, your calculator with fresh batteries because you don't want your calculator to run out halfway when you're trying to do the calculations. And also make sure you have your ID and exam slip to prove to the invigilator that you are who you are. Also, make sure that you go to the washroom before queuing up to go into the examination hall. Now, although some invigilators may allow you to go to the washroom during the examination, you know that every minute you go to the washroom, that reduces the time you have to answer the questions. Look, it's only an hour and 15 minutes. I'm sure you'll be able to last through the entire time without visiting the washroom. So make sure you empty your bladders before you go in. My suggestion, only go to the washroom if it's a real emergency. At the start of the exam, make sure you follow the instructions of the invigilator. Don't try to do anything before the invigilator gives you instructions to. Now, usually the instructions given by the invigilators would include checking that you have the correct examination paper. If you're in there for a physics exam and you've got a paper for chemistry, don't open the paper and start doing it. You gotta let the invigilator know, wrong paper. Now, the invigilator will also give instructions to all of you on when you can start writing your name, center number, and candidate number on the examination paper. Only write all this when instructions are given. During the exam, make sure you stay in your seat. Do not attempt to try to stand up, walk around, or look around. If you need something from the invigilators or assistance of any sort, raise your hand. The invigilator will come to you. Do not walk to the invigilator. This is because if you walk around or look around, this actually indicates that you are trying to cheat, because by walking or looking around, you'll be able to see the answers on the other candidates' papers. At the end of the examination, put your pens and pencils down when instructed to. Tie your papers up if you need to. So for example, if you needed additional examination paper, you need to tie them up together so that it is one set which can be handed to the examiner. Stay in your seat, wait for your paper to be collected. You may only leave the examination hall when instructed. So all of these are the general do's and don'ts when it comes to examinations. There may be some differences depending on your examination center, but no matter what, just make sure you always follow the instructions of the invigilator. Now, when it comes to asking for assistance during the examination, do not ask the invigilator for assistance unless absolutely necessary. Any unnecessary questions will be dismissed. Persistent questioning will be written in the vigilator's report, which can cause marks to be deducted from your grade. For example, if you try to ask invigilator to clarify any part of the content of the question paper or for any answer to the content of the question paper. Now, there may be exceptions only in very special circumstances. For example, if special access arrangements are required by the student. Special access arrangements are for students with disabilities. So, for example, they have trouble reading the paper or they're not able to write. Usually, this kind of special access has to be arranged in advance and only by students who qualify for the special access arrangements. Now, what kind of assistance can you ask for which will not cause any mark deduction? As long as, of course, you're not asking for any help with the question paper itself. For example, if you're asking for additional writing paper, this might be needed, for example, if you run out of space on your exam paper. That's fine. Now, let's get to the answering technique. How to answer the questions in paper 4. Now, some key things you must take note when answering the questions. If it's a calculation question, you must show your working. This is because not everyone is perfect. Sometimes you might make a mistake in your calculation, which means that your final answer will be incorrect. By showing the working, that means you show the equation and substitution. If any of those are correct, you can still get marks for that segment. So you don't get an immediate 0 for that particular question. Your answers should be written clearly in the space provided. This is especially for calculation questions, where the question will provide a blank space for the final answer. Make sure you write that final value in that space provided. Final answers that are numbered values must have units. The exception to this rule is if the unit is already provided or it doesn't exist. For example, refractive index doesn't have a unit. And the numbers that you write must be in 2 to 3 significant figures. So if your answer has only one significant figure, for example, if it's a nice integer like a number 3, make sure you write 3.0. Add a decimal for trailing 0 to make it 2 significant figures. Or if your calculation has many digits, then round it to 2 to 3 significant figures. The only exception to this rule is if the final number cannot be written in any other way. For example, if the number is a perfect 1000. So you can't make 1000 become 2 to 3 significant figures, right? In that case, you leave the number as is. By the way, just to clarify, only the final answer needs to be in 2 to 3 significant figures. Sometimes when you're doing calculations, the numbers that you're using could be like 4 to 5 significant figures or even more. So when you're doing the calculations, numbers that you're substituting in the equation could have many significant figures. The value you could get for your answer could have many significant figures. It's just that the final answer you write should be rounded to 2 to 3 significant figures. So that's what I mean when I say the final answers. So remember, your calculated numbers could have many significant figures, but once you've gotten that final answer, round that final answer to 2 to 3 significant figures when you write it in the space provided. Alright, so now let's get to how to answer the questions. Now, when answering the questions in paper 4, you need to identify what the question is really asking. This is a list of some of the most commonly used command words you'll find in the exam paper. So when I say identify what the question is really asking, you must understand what type of answer each command word is looking for. So you'll find that these are the words that are commonly used in the questions in the paper. Calculate, of course, means that you need to use your calculator to calculate the number out. So when you see calculate, make sure you show your working. When you see define, sometimes you use the term meant by. This is asking for the definition. You could also see a question that asks you to state. So state tends to be a straightforward question. Normally it's a recall kind of question. For example, if you have to state the concept used in a particular situation. Describe normally requires you to write out the process, meaning step by step how something occurs. When you see explain, normally you have to go into a little bit more detail in terms of the physics concepts. Now, the examples I've just given is not definitive. You must also observe how the question is phrased, because there have been some questions I've seen in the past year where explain only requires a very simple recall question instead of writing out a detailed explanation. So let's take a look at some examples on the next few slides. Now, what I'm going to do on these slides is I'm not going to go through in detail how to answer all these questions. Rather, we're going to be examining how the question is phrased, and we'll take a look at the mark scheme to see what kind of answer that they're looking for. So I'm not going to be writing out the answers to all these questions. Let's take a look at this question. So this question is taken from the Winter 2023 paper, variant 1. We have a situation where the girl holds a rubber ball out of a window of a tall building. They give you the mass as well as the position of the ball. So you can see for this question, they ask you to do a lot of calculations. This calculation comes out in 1A, 1B1, as well as 1B3. So you can see that for all the calculation questions, there's a space provided here. This is where you write your final answer into the three significant figures with the correct units. Now, for this question, this is a show question. And for show questions, they're a little bit different because although this is a calculation question, they've given you the final answer here. You need to show that the value you obtain is equal to this number. We'll look at how to solve this question shortly. So whenever you want to do the calculations, you have to make sure that you show the workings. So as you can see, marks are allocated for the working. So just to explain a little bit, A2 here means that if you got the answer numerically correct, you get the full 2 marks, regardless of whatever your working is. But remember I mentioned earlier, if you mess up the calculation, your final answer would be incorrect. So if you had written out the equation and the working, and you got them correct, you would at least get 1 mark for this, even if your final answer is incorrect. So that's what this marking scheme here means. Now let's look at 1B2. Now 1B2 says, show that the change in momentum of the ball when it bounces off the path is 5.2 kilogram meters per second. This question is a calculation question, but it's a proving kind of calculation. You need to prove that the change in momentum is 5.2 kilograms meters per second. So when solving this question, you do not start with 5.2. I've had students in the past who make this mistake. They saw, oh, change in momentum is 5.2. They start off by writing change in momentum is 5.2 and they go on from there. That's not how you answer this question. When you have to show something, you treat this as if you were required to calculate this. That means you want to calculate the change in momentum, you solve it until you get to that final answer, and your final answer must be the same as 5.2. So in a way, I consider this kind of question as free marks because they've already given you the answer. You just need to prove this. Now, in case you don't understand this marking scheme, I'll just show you real quickly how to solve this kind of question. So for example, you could write the change in momentum is equal to the final momentum minus the initial momentum. I'm going to write the symbols over here. So all these values could be obtained from the first part of the question. We know that the mass is 0.20 kilograms. The speed of the ball before it strikes is 14 meters per second and after is 12 meters per second. So we're going to substitute that into this equation. So this would be 0.20 times 12 minus 0.20 times 14. But here's the thing, when it strikes, it's going to bounce up. So if we take going down as positive, that means going up is negative. Therefore, this should be negative 12. So you must make sure that you don't leave the negative out because in the formula, momentum is mass times velocity. Velocity is a vector. So when you solve this, you're going to get negative 5.2 kilograms meters per second. Now the mark scheme does say that it should be a positive, and for some reason they're using mu minus mv instead. Personally, I think that you still get correct answer because it is, after all, final momentum minus initial momentum. But if you want to be on the safe side, because change of momentum normally is a magnitude, you can write in the end here that the change of momentum is based on a magnitude, which is 5.2 kilograms meters per second. So that's how you solve a show question. You treat this as if you are supposed to calculate this value and the final number should be equal to the value they've given to you in the question. Now for the last question, it's a calculation question again. So all you have to do is just use the correct formula, get the correct answer, and write the answer in the space provided. Now let's move on and take a look at another question. So this question is taken from Winter 2024 variant 1. So you can see for this question, they're using all the command words that we saw in the earlier slide. There's a define, describe, explain, calculate, as well as state. But here's the thing, don't just jump in and answer the question just based on the word that they use. You have to read the question carefully. What do I mean by this? So let's start first with 3A. So define a moment of a force. Define here means you need to give the definition, and as you can see from the mark scheme, you will get marks for writing the correct definition, which in this case, a moment is the force times perpendicular distance from the pivot. Now just to explain the mark scheme, 2 marks are given for the correct definition because this definition is very, very particular compared to a lot of the other kinds of definitions. For example, some students may only write force times distance, or you only mention something to do with perpendicular distance or perpendicular force. So if you didn't write the full definition out, you wouldn't get 2 marks, but you could still potentially get 1 mark if you wrote any of these things. So that's what this mark allocation means in this mark scheme. Now, in terms of describing the effect that it measures, it's measuring the turning effect of a force. So this is describing what the concept of moment is in terms of its measurement. Now let's take a look at B1. Explain what is meant by center of gravity. Earlier, I did mention that explain means you need to go into detail about this concept. But here's the thing. The question says, what is meant by center of gravity? The moment you see the term meant by, this means that they're asking you for the definition. So regardless of whatever word they use here, in this case, meant by takes precedence. That means you need to give the definition of center of gravity. That's why in the mark scheme you can see here, this is the definition of center of gravity, the point where all of the weight of an object seems to act. So that's what I mean when I say you have to read the question carefully. For question B2, they're asking you to do the calculation. As we've already discussed, you need to do the calculation and write the answer here in the space provided. Make sure you write the working out just in case. If you got the correct answer, of course, you'll get 2 marks. For question C, they ask you to state the 2 conditions that apply when an object is in equilibrium. So like I mentioned earlier, the term state normally is a recall question. So you just need to recall what are the 2 conditions for the object to be in equilibrium. And you can see from the mark scheme here, the resultant force must be 0 and the resultant moment must be 0. Or written out something to that effect. Here's another question from the same paper. This is question 4. I didn't put out the entire question 4. I've only put in an extract because I want to show you that for this question, they use the term explain 3 times because they want you to explain 3 different things. In this case, unlike the earlier question, you can see that all 3 questions here require you to go into a little bit more detail about these respective concepts. So, for example, B1, explain why after a short time, the dish and water are the same temperature. And as you can see from the mark scheme, you need to explain what's happening in terms of energy that causes a dish and water to end up being at the same temperature. So this is not a recall question. This is not a definition question. You need to use your understanding of thermal energy transfer to explain how this happens. For question 2, explain in terms of its particles why the aluminium expands as the boiling water is poured into the dish. Also, again, you need to use your understanding of thermal expansion to explain what's happening to the aluminium, as you can see from the mark scheme here. And for question 3, the water in the dish evaporates. Explain in terms of the water molecules what is meant by evaporation. So you need to use your understanding of the evaporation process and explain that process in terms of what's happening with the water molecules. Now don't assume that entire block of question is always necessarily from one unit only. It is possible that sometimes different units could be combined into the same question. So for example, from the winter 2024 paper variant 3, you can see that question 6 looks like an electricity question. You can see for question 6A, they're showing you 2 circuits with 3 identical resistors. And in question A1, they want you to describe 2 advantages of using circuit B. So of course, in this case, you need to recognize that circuit B is a parallel circuit, and you need to describe the 2 advantages of a parallel circuit compared to a series circuit. But when you come to number 2, suddenly the question changes. Describe, in terms of the water particles, the process by which the water droplets are removed from the car windscreen using the heater. So if you have your mind set on electricity, suddenly when you look at this question, you'll be like, what has this got to do with electricity? So be flexible and adapt quickly. This question is not an electricity question. This is related to thermal physics. So when heat is applied to the water droplets, they're going to evaporate from the screen. As you can see from the mark scheme here, the related answers are about evaporation. So this process obviously is not about electrical circuit, it's about evaporation. You've got 2 units within the same question block. Now I want to stress again and again and again, always read the question carefully, because sometimes they can phrase a question in a confusing way that you think they're asking you about one thing, but really they're asking you for another. So yes, sometimes they will tell you grandfather stories before the actual question, which have nothing to do with what they want you to answer. Now, this isn't true for all questions. Most of the time, they'll give you a prelude, which kind of hints to what they want you to answer, but sometimes they'll give you something that has nothing to do with what they really want you to say. So let's take a look at some examples. So this is an extract from one of the questions in summer 2024, variant 2. The question is, the container is made of steel and there is a vacuum between the inner and outer walls. The outer wall of the container is at room temperature. State 2 methods of thermal energy transfer that a vacuum prevents. Now, this question is related, so you'll see that most questions are phrased this way. They'll give you some kind of introduction and then they'll give you the actual question. So you'll find there is some relationship, but if you look at the question carefully, even if they don't give you this paragraph, you can still answer the question. That means that if this part of the question doesn't exist, you just see, oh, state 2 methods of thermal energy transfer that a vacuum prevents, you can still answer the question straight away. Now, I'm not telling you to skip this part of the paragraph, but you can see that the real question is in the final line over here. In this case, there is a relationship between the first paragraph and the actual question, but when you look at it carefully, you don't actually need the first paragraph. Now, this question is not an example of what I'm talking about. I'm just showing you this is the typical kind of question you would see most of the time. What you have to be careful of is when the question has nothing to do with the earlier paragraph. Now, this is an extract of a question from summer 2021 paper variant 1. Nuclear fusion in the sun is the source of most, but not all of the resources that are used to generate electrical energy on Earth. State 2 resources for which nuclear fusion in the sun is not the source. Again, this is very similar to the earlier question. The line before this has something to do with the question, but if you read the question carefully, you don't even need the first line in the first place. You can answer the questions directly based on this question itself. And yes, the answer to this question is what I call the TNG concept. The 3 energy resources for which the sun is not the source of is tidal, nuclear, geothermal, TNG. So still not so bad in terms of the questions, but let's take a look at the next slide. This is an extract from the summer 2021 paper variant 3. Radioactive sources have many uses in medicine. State 2 safety precautions which hospital staff take when working with gamma ray sources. Now, they may look related, but if you read the question carefully, this has nothing to do with medicine or hospital. This is a safety precaution question, which means that they're asking you a general safety precaution that should be taken when working with gamma ray sources. So these safety precautions apply not only for the hospital, but for any industry in general which work with gamma rays. So don't let certain terms confuse you. This is not about medicine or hospital. This is about the gamma ray sources, as you can see from the mark scheme here. So this is one of the examples I mean when I say you've got to read the question carefully. Still not so bad, right? Now let's take a look at this question. This is an extract from the summer 2022 paper, variant 1. As the water in the cloth cools, so does the laminate. Explain how electrons transfer thermal energy through the metal of the can. So this question has confused and frustrated many of my students because they ended up writing the wrong answer. Now, if you look closely at the question, you can see that the first and second sentence are actually not related. The first sentence talks about how the water and the laminate cool down, but the actual question is asking about how electrons transfer thermal energy. And as you can see from the mark scheme, yes, this is exactly about how electrons can transfer thermal energy easily through metal. So some students, when they read this question, they start answering in terms of how the water and the laminate cool down instead of talking about the electrons. You can see from the mark scheme here, nothing to do with the water or the cloth or the laminate. So this is what I mean when I say you have to read the question carefully. The first part of the question has nothing to do with the actual question. Now, fortunately, this is not a common thing that happens in the IGCSE paper. When I looked at the past year questions, most of them have an introduction which is related, and sometimes the introduction even helps students answer the actual question. But yes, sometimes you do come across this kind of tricky, sneaky questions. So my advice is always read the last line very, very carefully and then re-examine the first part of the question to see, does it really help with coming up with the answer for the question? Now, a particular concept which I find that many of my students tend to get confused about is this particular concept, which is why I have selected this particular concept and highlighted it in this part of the video. The concept in question is explaining gas pressure versus explaining how gas pressure changes. Now, what is it that the students find confusing? Let's take a look at the next couple of slides at the example of questions. So this is an extract from Winter 2022 paper variant 2. Question 4a. Explain in terms of the momentum of particles how a gas exerts a pressure. Now, this question is asking how gas particles are able to exert a pressure. As you should have learned in the topic of gas pressure, you must be able to explain this in terms of momentum. So as you can see in the answer scheme here, you need to talk about how moving particles have momentum or that the particles hit the walls. And this causes a change in momentum. Force is exerted due to the change of momentum, and pressure is the total force per unit area. This question is asking how the gas particles exert pressure. I've seen a lot of students tend to get confused and start explaining how the change in gas pressure occurs instead. Obviously, there's no change in any gas pressure here. A change in gas pressure question would look something like this. This is an extract from Winter 2023 paper variant 2. A. The temperature of the bottle and its contents are increased. 1. Explain in terms of particles how the air pressure inside the bottle changes as the temperature increases. This question now is very clearly asking about how the gas pressure changes because they've given us a situation where something else has changed, causing the gas pressure to change. So when answering this question, we need to talk about those changes. So you need to start off first with what's causing the change in gas pressure. So the temperature has increased. This causes the increase in the average kinetic energy or average speed of the air particles, causing more frequent collisions or more forceful collisions of the air particles with the bottle. So greater force per unit area gives greater pressure, while the volume remains unchanged. That's why the pressure increases. So as you can see from the mark scheme here, there's a lot of explanation involving changes. For example, an increase, there's more, greater. So this is because the question is asking for the change in air pressure when the temperature increases. Let's backtrack to the previous question. You can see that this question has nothing to do with changes. This is asking in general how the gas exerts pressure. So I find that a lot of students tend to answer this question, which is asking in general how gas exerts a pressure, using this kind of answer because this seems to be a lot easier for most students to understand. They understand, oh, when there's a change in temperature, there's a change in pressure. So they tend to talk about temperature and pressure. But you can see in the previous question, this has nothing to do with temperature. So I know that for some of you, you'll be like, that's pretty obvious, there's no changes here. But as a teacher, I've seen a lot of students tend to make this mistake. So I'm just highlighting for those students who tend to fall into that trap of talking about changes instead. So be careful when you answer the questions. When you see gas pressure, don't straight away jump into answering the question based on what you know. For example, you might think, oh, I already know, yes, a change in temperature causes a change in pressure. As you can see in this question, there is nothing that's causing a change in pressure. It's just asking in general how the gas exerts a pressure. This question gives us a situation where the temperature has increased, causing the change in air pressure. So you give an answer accordingly, talking first about how the temperature change affects the air particles, which then causes the air pressure to change, as shown here in the mark scheme. Now let's move on. So it's very important that as students, you know what's in the syllabus guide, because a lot of the information is right there in the syllabus guide. So this video is designed for those in the 2023 to 2025 cohort, but for those of you who are taking the 2026 to 2028 papers, your syllabus is actually exactly the same in terms of the content. But to be on the safe side, please download the syllabus guide and the learner's guide for your particular year of examination. Regardless of whatever year you're taking the paper, this advice still applies. Now, just to let you know, I'm the kind of teacher that when I teach in class, I actually refer to the syllabus guide. I go through it line by line with my students. Not all teachers do that. Most teachers prefer to follow the flow in a textbook. There's nothing wrong with either way. Every teacher has their own way. It's just that personally for me, I always follow the syllabus guide because I want to make sure that we've covered everything the students need to know in the syllabus to make sure they can answer all the questions in the examination. In fact, I've got some students who have even argued about certain answers that appear in a mark scheme based on the question because it didn't make sense to them. But actually, it was right there in the syllabus guide all the time. So, what do I mean when I say that some information is right there in the syllabus guide? Let's take a look at some examples from past year questions. So this is an extract from the summer 2023 paper variant 2. Two types of seismic waves are P waves and S waves. A. State the types of wave that P waves and S waves can be modeled as. So for this question, it's pretty straightforward. If you've learned about the different types of waves, you would obviously know that P waves are longitudinal and S waves are transverse. However, I've had some students who in the past didn't quite pay attention and didn't really quite read the text clearly, while wondering what on earth are P and S waves. The thing is, they're already right here in the syllabus guide. So here in these black boxes are extracts from the syllabus guide. You're expected to know that for a transverse wave, seismic S waves can be modeled as transverse, whereas for the longitudinal, seismic P waves can be modeled as longitudinal. In fact, that's all you need to know about seismic S and seismic P waves. You don't need to know what they are. You don't need to explain how they happen. Now, you'll probably be able to answer this even without referring to the syllabus guide. Let's take a look at some other examples. This is an extract from the summer 2024 paper variant 2. Figure 10.1 shows the orbit of an object around the sun. At point A, the object is closer to the sun. At point B, the object is furthest away from the sun. State and explain the energy transfer as the object travels from point A to point B. Again, this is something that you would have learned in class when you were learning about elliptical orbits. But to help you answer the question, actually you can just refer to what's in the syllabus guide. The answer scheme here says that the kinetic energy decreases and potential energy stored increases as object moves from A to B while the energy is conserved. If you had paid attention to your teacher, you would know this, but I've got some students who'll be like, how on earth do we even know this in the first place? It's right there in the syllabus guide. So this sentence here in this black box is an extract from the syllabus guide. You need to know that an object in an elliptical orbit travels faster when closer to the sun, and explain this using the conservation of energy. So although they don't talk about kinetic and potential energy here, but it did say that you are supposed to know how to explain this. So this is based on the change between kinetic and potential energy, and this is explained using the conservation of energy. Here's another example. This is an extract from Winter 2023 paper variant 1. The question is, one reason for using an isotope that emits alpha particles in a smoke detector is that alpha particles are more strongly ionizing than beta particles. Explain why alpha particles are more strongly ionizing than beta particles. Now, just to explain to you, if you were to ask someone in the radioactive industry, or if you had watched videos from experts who explain about alpha and beta particles, you might find that they give very much more detailed explanation that has nothing to do with the mark scheme as you can see over here. And the reason I can say this is because I myself have attended a course on radioactivity that explains a lot of things in much greater detail than what we've actually covered in this syllabus. So when I first explained why alpha particles are more strongly ionizing than beta particles to my students, I did not use this explanation, and I myself was pretty surprised when I saw these answers. And then I realized that the reason why the answer is as such is because this is taken from the syllabus guide. So to explain why alpha particles are more strongly ionizing than beta particles, you need to talk about the relative ionizing effects with reference to the kinetic energy as well as the electric charge. So all other explanations, even though they may be true in real life, will not be accepted because that's not what is stated in the syllabus guide. So alpha particles are said to have greater ionizing effects than beta particles because they have more kinetic energy because of the greater mass, and they also have more charge than beta particles because, as you should know by now, alpha is positive 2 while beta is negative 1. So regardless of whatever you might have learned from other sources, you have to explain your answer based on what is in the syllabus guide and what's in the syllabus guide only. Let's go through a few more examples of reference to the syllabus guide. This is an extract from the summer 2023 paper variant 1. State 2 reasons why microwaves are used for mobile phone or cell phone signals. You don't have to crack your head for this answer. Just to think about, oh, microwaves are higher frequency radio waves, and try to figure out how that fits in. You don't need to overthink it. Why? Because the answers are right there in the syllabus guide. As stated here in the syllabus guide, you need to know that many important systems of communications rely on electromagnetic radiation, including that mobile phones and wireless internet, mobile phones or cell phones, and wireless internet use microwaves because microwaves can penetrate some walls and only require a short area for transmission and reception. And as you can see, answers in the mark scheme are using the exact same 2 reasons that are already written right there in the syllabus guide. Only need short aerials or antennas and can penetrate some walls. So as I had mentioned at the beginning of the video, state is a recall type of question. You just need to recall what is written here in the syllabus guide. Let's go through one more example. This is an extract from the winter 2023 paper variant 2. Suggest why a Bluetooth headset only works well over short distances. Again, you don't have to crack your head, try to figure out what Bluetooth, I don't know what. It's right here in the syllabus guide. In point B, Bluetooth uses radio waves because radio waves pass through walls, but the signal is weakened on doing so. So as you can see from the mark scheme here, you just need to write about how the radio waves lose energy or get weaker or lose signal strength when passing through walls, or words to that effect. So you talk about radio waves because you need to know that Bluetooth uses radio waves and they only work well over short distance because of these reasons, which are already written here in the syllabus guide. So yes, knowing the syllabus guide well will really help you come up with the answers for these kind of questions. One more example. This is an extract from the winter 2024 paper variant 1. Astronomers determine the speed and distance from the Earth of a far galaxy that is moving away from the Earth. So you've got a whole bunch of different questions from the space physics unit, while the answer to all 4 of these questions are right there in the syllabus guide, as you can see from this extract I've put on the right side here. So let's start with C1. You need to state the observation that allows the speed at which a galaxy is moving away to be determined. The answer to that can be found in point 7. The speed at which a galaxy is moving away can be found from the change in wavelength of the galaxy's starlight due to redshift. And as you can see, the answer in the mark scheme here is exactly that, the increase in wavelength of a light from far galaxy or the amount of redshift. For question 2, state one different observation that is used to determine the distance to a far galaxy. The answer to this can be found in point 8. It's determined using the brightness of a supernova in that galaxy. And as you can see, the answer for that question, brightness of a supernova. For question 3, state how the speeds of galaxies and their distances from the Earth are related. This answer can be found somewhat in point 9, not directly, but you can derive the answer from point 9. The Hubble constant is the ratio of the speed at which a galaxy is moving away from the Earth to its distance from the Earth. So if you have a constant ratio that relates V to D, that means V is directly proportional to D. And as you can see from the answer here, speeds are directly proportional to distance from Earth. Or you can even use the Hubble constant formula of h0 equals V over D, exactly as written here in point 9 of the syllabus guide. For question 4, to calculate an estimate for the age of the universe, the answer for this, as you can see, is based on point 11. You need to know the equation of d over v equals 1 over h0 represents an estimate for the age of the universe. So to calculate the age of the universe, you just need to take the calculation of the inverse of the Hubble constant. And as you can see from the mark scheme, you just calculate 1 over h0. Use your calculator, you can get the answer of 4.5 times 10 to the power of 17 seconds. So if you know what's in the syllabus guide, that's really going to help you answer a lot of the questions in your exam paper. Now, let's go through some skills which you should know when preparing for your exam papers. For one, you need to be able to draw or calculate resultant vectors in vector diagrams. So these kind of questions don't come out every year. They do come out often enough because obviously this is a skill that you must have. So let's go through some past year questions. I'm not going to be going through the answers right now. I'm just showing you the examples of the questions. If you can't remember how to solve vector questions, please watch my video on how to draw and calculate resultant vectors. For now, I'm just showing you proof that you need to know this. This is an extract from the summer 2023 paper variant 1. As you can see, this is a velocity question, and you need to determine the magnitude and direction of the swimmer's velocity, given that the swimmer is trying to swim straight across, but there's a current that's pushing the swimmer to the left. So to solve this, you can either draw the answer out or you can calculate the answer out using the triangle method or the rectangle method. Here's another example taken from the winter 23 paper variant 2. This is now a force question where the question shows you two different forces acting on a balloon, one acting downwards and one acting to the right. Again, to determine the magnitude and direction, you can either draw it out or you can calculate it and solve the question using the triangle method or the rectangle method. So if you don't know what I'm referring to, please watch my video on how to solve resultant vectors. One more example just to prove my point. This is taken from the summer 2024 paper variant 2. You need to solve the resultant forces acting on this situation where you have a load suspended from a thread, there's tension in the horizontal wire of 1.2 Newton, and there's a force pulling it horizontally to the right. So this diagram doesn't show you the full situation. You need to figure out what the new diagram looks like and work out the answer. Now, other skills that you should have, you should also know how to draw the light rays that undergo total internal reflection. Although this is not a question that comes out every year, it's come out often enough that you should know how to draw this. And it's so simple. Honestly, if you get this right, that's 2 marks right there for you, easy peasy. So an example of this is taken from the summer 2023 paper variant 3. Figure 5.1 shows an optical fiber made out of the glass described in 1, an earlier part of the question. On figure 5.1, draw carefully a ray of light in a fiber undergoing total internal reflection. So when drawing the answer, you need to start from one end and finish on the other end. Whatever angle you draw the ray of light in, it doesn't matter as long as you show clearly that it's undergoing total internal reflection. So just to show you an example, I've got an arrow here. This is going to represent the incident ray. I say it travels in from the left side, and you draw a straight line until it touches the boundary between the optical fiber and the air. Now it's going to undergo total internal reflection. You need to show clearly that it obeys the law of reflection, where the angle of incidence is equal to the angle of reflection. So it's a good idea to draw a normal line at the point where the incident ray reaches the boundary. That way you can see the approximate value of the incident angle more clearly. So that will help you draw the reflected ray at a more accurate reflected angle. Now the angle doesn't actually have to be exactly the same. As long as it visually looks the same, most examiners will accept it. If you want to be on the safe side, feel free to use your protractor just to double check. Now I've got my light ray here. Let's try to make the angle equal on both sides. Now we want to try to make the angle equal. Now depending on what angle you drew your light ray at, your light ray might touch this boundary, it might touch that boundary, it might even go all the way out. It doesn't matter as long as you show clearly that your ray of light is undergoing total internal reflection. In my case, the light ray is probably going to go up to here. I'm going to visually try to make the angles look the same. So the light ray I have drawn hasn't completely exited the optical fiber on the right side, which means it's going to undergo a second total internal reflection. That's perfectly fine. In fact, it is highly recommended actually that you show multiple total internal reflection. So instead of having just one, if you could draw at least 2 points of total internal reflection, it's likely you'll get full marks rather than just drawing a single total internal reflection. So if you've got one more light ray, just going to fix this. And we're going to make the angle same on both sides for this particular point of total internal reflection. There you go. So you can see that in my diagram, I have 2 points of total internal reflection, and the angles are equal on both sides for each respective point where the total internal reflection has occurred. So although it's not stated, again, remember that it is recommended try to show at least 2 points of total internal reflection, because that kind of diagram would then show clearly that light rays easily undergo total internal reflection. No matter how the fiber is bent, the light ray can still travel all the way from one end to the other end because of total internal reflection. Let's move on to the next tip you should know. Some answers clearly should not be repeated, especially if the factors are clearly different. Now, why am I saying this? This should be pretty obvious to some of you, but I have had some students who write the same answers in a different part of the question when they've already given those same answers at the top part of the same question. So, although this is clearly not rocket science, I feel I have to mention this anyway. So, one of the clearest examples of this would be for diffraction. This is an extract from the Winter 2023 paper, variant 3. Question 5a. Figure 5.1 is a scale diagram of wavefronts of red light approaching a gap in a barrier. On figure 5.1, draw 3 wavefronts after the wave has passed through the gap. So I've had some students who are not sure what to draw over here. Well, as you should have known by now, you need to compare the size of the gap against the wavelength. But here's a tip for you. If the same question asks you to draw something 2 times, you can actually use the second diagram to help you figure out what you need to draw in both diagrams. As you can see in question B, figure 5.2 shows the same barrier and gap. A wave of blue light approaches this barrier. So for this diagram, you need to draw the 3 wavefronts of this wave before it reaches a barrier and 3 wavefronts after the wave passes through the gap. So for question B, what you draw before the gap, you just draw the 3 lines just like what you see in figure 5.1. The point of confusion is what you'll be drawing after the barriers. As you should have learned in diffraction, there are only 2 shapes of the waves that you need to learn after the waves pass through the gap. One is where the waves are circular, another is where the waves have straight lines with curved edges. The problem is, which diagram do you draw? So if you were going to draw circular waves on one diagram, obviously the other diagram cannot be circular waves. It will have to be the other one, the straight line with the curved edges. Why can't you draw the same waves in both diagrams? Because clearly the purpose of this examination is to test, can you tell the difference between the 2 situations? So no, you would not be asked to draw the exact same thing in both diagrams. If you draw the wave one way in one diagram, it will be the other in the other diagram. So how to determine this? You can either compare the gap size against the wavelength or compare these 2 diagrams. As you can see in both diagrams, the gap sizes are the same. But in question A, the wave is a red light, while in question B, the wave is a blue light. Red light has a longer wavelength than blue light. Therefore, in question A, figure 5.1, you need to draw the circular waves, whereas in B, you draw the other shape, the straight line with curved edges. This is because, as you should have known by now, the greater the wavelength, the more obvious the diffraction, therefore the wave would be circular. So as you can see in question 5a, the answer scheme says here, you need to draw the semicircular wave crest. whereas in question B, you draw waves with reduced curvature. So actually, when you get a question like this, it is a lot easier to get the answer correct. Because if you have a question with only one diagram required, no second diagram, then you have to figure out, is it going to be the circular wave or the reduced curvature wave? Now let's move on to the next tip. You'd also need to be able to explain some of the processes that you've learned in physics. For example, one process you need to know how to explain is the cooling process of evaporation. So here's an extract from the summer 2022 paper variant 1. During a picnic on a warm, dry day, a metal can of lemonade is wrapped in a damp cloth. Evaporation cools the water in the cloth. A. Explain in terms of molecules how evaporation cools the water in the cloth. So this is a process which you should be able to explain, not only explaining the process of evaporation, but how that process is able to produce a cooling effect. So as you can see from the mark scheme here, you need to talk about how the faster, higher speed or more energetic molecules escape into air, causing the average speed or average kinetic energy of the molecules remaining in the water to decrease. Then you need to explain how the temperature decreases related to the speed or energy of the molecules, or you can mention that the slower or lower speed or lower energetic molecules remain in water. So this process you should have already learned by now, and you need to be able to explain it again in terms of how evaporation occurs and how it creates a cooling effect. Another process which you should be able to explain is the operating principle of a simple transformer. I've included the extract from the syllabus guide here just to remind you that you need to be able to explain the principle of operation of a simple iron core transformer. So this is an extract from the summer 2023 paper variant 1. The electricity supplied to a town is transmitted using a high voltage cable. A transformer in the town has a soft iron core. A. Explain the principle of operation of a simple iron core transformer. As you can see, this question is word for word taken from the syllabus guide. Anyway, so how do we explain it? You should know this by now, but just to make sure that you have all the points that you need to know, let's refer to the mark scheme. So you can see that you can score any of the 4 points from these following statements. The mention of alternating current in a primary coil, which generates a changing magnetic field. The iron core concentrates a magnetic field or transfers a magnetic field to the secondary coil. The secondary coil is within the alternating or changing magnetic field, or the secondary coil cuts a magnetic field, causing the EMF to be induced in the secondary coil. So just to remind you, when you want to explain processes in physics, remember that it's a step-by-step process. So in case you're worried that you're going to miss anything out, start from the very beginning and go through it step by step. So for example, in a transformer, you know that you have to start off with the input, which is the primary coil. So there's alternating current in a primary coil. This is then transferred to the middle part of the transformer, which is the iron core. So you can see there's explanation about what iron core does, and then you talk about the secondary coil. So when you go through it step by step, starting from the beginning, you'll be able to cover all the points needed to score full marks. Now, this is very straightforward, but sometimes you could come across questions where they will ask about the transformer, but phrased in a different way. So, for example, this is an extract from the winter 2024 paper variant 1. A square coil of many turns is placed close to the bar. Figure 7.3 shows a plane of the square coil parallel to the flat circular surface at the right-hand end of the bar. The resistance of the variable resistor is alternately increased and decreased. Explain what happens in the wires of the square coil. So this is not a transformer, and in fact some students will be like, oh my god, what's going on here? They don't mention transformer, but if you read carefully and you understand what's happening here, you can see that this is actually behaving similarly to a transformer, because the resistance is alternately increased and decreased, causing the current value to change. So the changing resistance causes a changing current, which causes a changing magnetic field. And the purpose of the square coil placed here is to cut the magnetic field to induce EMF. So although they don't explicitly say that this is a transformer, the behavior of this setup mimics that of a transformer, which is why the answers in the mark scheme here is based on the operating principle of a simple transformer. Here's one more example. This is taken from the Winter 2024 Variant 2 paper. Figure 9.1 shows a wireless charging plate used to charge the battery in a mobile phone or cell phone. The coil of the wire is part of an electric circuit. The charging plate is connected to an AC power supply. The power supply is turned on. A. Describe the magnetic field around the charging plate in terms of its magnitude and direction. So this part of the question is not yet about transformers. It's just generally about how electromagnetic fields are formed. So because you have an AC power supply, alternating current has changing magnitude and changing direction, which is why the magnetic field also has changing magnitude and changing direction, as you can see from the mark scheme here. For question B, a mobile phone is placed on a charging plate as shown in figure 9.2. The coil in the mobile phone is part of a separate circuit that charges the battery. The coil in the charging plate and the coil in the mobile phone act like a transformer. So here, the question has already given a hint that this is a transformer-based question. So explain why there is a current in the secondary coil shown in figure 9.2. This is about how the secondary coil is able to get current, and you can see that the answer is similar to that of our understanding of how a transformer works. The secondary coil is in the changing varying magnetic field, or you can say the secondary coil is in the magnetic field of the primary coil, causing the voltage to be induced. Suggest why the transformer made from the charging plate and mobile phone is not 100% efficient. This question is an efficiency question about transformers. And you can refer to the answer here. You might find, oh, I haven't learned any of this, but if you understand transformers, you should be able to come up with the answers. Now, let's go through half-life. There are some information that you need to know about half-life which is not mentioned in the syllabus guide. Fortunately, not that much. So why I'm highlighting this is because there were some questions in the past year papers where my students looked at it and they're like, how do we know these answers? And when I looked through the syllabus guide, no, it was not even mentioned in the syllabus guide. Fortunately, we do have the past year questions and the mark schemes to refer to. So even though they're not covered in the syllabus guide, it's important to note this so that you can answer the questions just in case it comes out in your exams. What is information that I'm referring to? Let's look at the next few slides. This is an extract from the Winter 2023 paper, Variant 1. The isotope of neptunium produced by americium-241 is also radioactive. The decay of this isotope of neptunium produces an isotope of protactinium which decays by beta emission. Beta particles are more penetrating than alpha particles. The half-life of neptunium is longer than 2 million years. Using this information, explain the advantage of this long half-life for the use and safe disposal of a household smoke alarm. Okay, so this question was really long, and if you remember what I mentioned in an earlier part of this video, sometimes it'll give you grandfather stories that have nothing to do with the actual question. Yeah, so you can see that all this talk about neptunium and beta particle emission has nothing to do with what the question is actually asking for. They want you to explain the advantage of this long half-life. The long half-life they're referring to here is the half-life of neptunium, which is longer than 2 million years. So this is not in the syllabus guide. Trust me, I've looked through the syllabus guide to look for this information, which means that this is extra information that you need to know. So what's an advantage of a long half-life? Based on our mark scheme, you can see here, the advantage is that there's lower initial activity or few emissions per unit time. What this means is that because the half-life is so long, longer than 2 million years, this means that the time it takes for the activity or the amount of beta emission to drop to half the initial value is more than 2 million years. So if it starts with this value to drop to half, more than 2 million years. That means throughout the time for it to drop to half, because it takes such a long time, there's very little emission over the 2 million years. So that's what they mean over here. Because there's so few emissions, this suggests that it's safer for use. So for the safe disposal of a household smoke alarm, you can mention that smoke detectors are not hazardous to humans, or you can dispose of the old detectors in a cheap and easy way. Now this is about long half-life. What about short half-life? So here's an extract from the summer 2023 paper Variant 1. Suggests one reason why isotopes with very short half-lives are especially hazardous. And in this case, this is the opposite to the previous question. You can see in the mark scheme here, it suggests that the large number of particles produced are in a short time, or there's a high or large decay rate, or high dose of radiation in a short time. What does this mean? If the half-life is very short, let's say for example 10 hours. So if it starts with an initial value, it drops to half in about 10 hours because it's such a short amount of time for it to drop. That means within the 10 hours, there's a lot of emission to try to drop to half within that 10 hours. That's why it says it has a high decay rate or a high dose of radiation in a short time, compared to 2 million years for it to drop to half. So be aware of the advantages and disadvantages of these long and short half-lives of radioisotopes. Now, additional stuff you need to know, not in your syllabus, but could still potentially be tested. This is not a paper 4 question, it's actually a paper 2 question, but I've had students who questioned how come we're supposed to know this. Now, this information is not in your syllabus, but could still be potentially tested. Now, this question is not from paper 4, it's from paper 2, but I've included it in this video just in case you might need to know this. So the question goes like this. Fission and fusion are two types of nuclear process. How does the total mass of the nuclides produced compare with the total mass of the original nuclide or nuclides in these nuclear processes? So comparing the total mass of fission products to the original, as well as total mass of fusion products compared to the original, are they the same? Are they more or less? So this particular topic actually is no longer in your syllabus. They were included in an earlier cohort, was actually taken out for the 2023 to 25 syllabus, as well as the 26 to 28 syllabus. What students had to be able to do originally was to be able to calculate the amount of energy based on the mass defect. Now, what I mean by mass defect, it's not a rude word. Mass defect here means the loss in mass. So for those of you who used to wonder about Einstein's formula of E equals mc squared, this is actually the energy mass conservation formula, which is used to calculate the amount of nuclear energy released during a nuclear reaction. So the mistake that a lot of students make is that they think, oh, fission is where it splits, so it becomes less, and fusion combines, therefore it's more. No, that's not what it is. It's asking for the total mass of products. That means before the reaction and after the reaction. In both cases, there'll be a loss in mass. That means the answer for this question is D, where in both fission and fusion, the total mass, not the individual mass of the atom, the total mass of all the products will be less than total mass of all the reactants of that reaction. What happened to the mass that was lost? They've been converted into energy. And that's what this formula is for. Now the good news is you don't need to know this formula, but you should be aware that the mass decreases. So how come this question still popped up even though it's no longer in the syllabus? Well, I don't have the answer to that, but in my opinion, this is still something that you should know as physics students if you're going to be learning about radioactivity and nuclear energy. So just be aware that yes, the mass decreases regardless of whether it's fission or fusion or any other kind of nuclear reaction. So my recommendation is that make sure you have all the skills listed in the learner's guide. So download the learner's guide and go through every line to check every skill you should have. This will help you determine what you do know and what you need to work on. If you don't have the learner's guide, you can download it for free from the Cambridge website, or you can download it from my website. I have put the link in the description below. Let's just go through the learner's guide briefly so that you know what it is and how to use it. So this is the learner's guide for the cohorts of 2023 to 2025. You can also download it for the 2026 to 2028 cohort just to be on the safe side if you're taking the exam for those years. So what is this learner's guide? There's a lot of information which you should go through, including some examples of questions. But the one that I want to focus on for this video right now is the skills which you should check. So here you've got the revision checklist, and this uses the traffic light system. What is a traffic light system? For the traffic light, we have red, amber, green. Red means you're really unsure and lack confidence. So you might want to focus your revision here, possibly talk to your teacher for help. Amber means you're reasonably confident but need some extra practice. Green means you're very confident. So how do we use this traffic light system? Let's scroll down a little bit. You can see here, starting from page 22, they have listed here all the skills divided into units as well as topics. Starting from here, Unit 1, motion, forces and energy. You've got different topics here, 1.1, 1.2, and so on and so forth. So every skill is written here with the traffic light system of red, amber, green on the side, as well as comments. How do you use this learner's guide? What you do is you read this skill and you put a check mark in the box where you feel represents your current skill. For example, if you feel very confident about your ability to describe the use of rulers and measuring cylinders to find a length or a volume, you put a check mark under the green box. However, if you feel okay, you're reasonably confident but need more practice, then you select amber. If you're like, oh my god, I don't even know how to use this at all, I need help, I need to learn this, then you select red. If there are any additional comments that you want to write, you can write it here. For example, you can write, do more past year questions, or speak to a teacher to learn more about this, or whatever else you would like to write. Now, this document is very long and comprehensive because there are so many skills that you need to be able to do, but I suggest in order to practice for your exams, please go through this learner's guide line by line. Why? Because sometimes there may be some skills which you did not learn. Now, it's possible that certain things may not be covered for whatever reason in the lesson, or sometimes it was covered in a lesson but you were not paying attention so you didn't get it, or sometimes it was covered in a lesson but you were not there, possibly because you missed the lesson due to illness, or you were away from class because you were doing something for the school or representing the school in some kind of competition, and check, do you have the confidence in this skill or not? That way you can identify what you know and what you don't know and what you need to work on. And that's it for this video. So I know this video has been pretty long, but I hope you found this video to be helpful in your preparation for your upcoming IGCSE examinations. Do check out my YouTube channel for videos on other topics which you might find helpful. If you'd like to help me keep making free educational video lessons and lab practicals, donations are welcomed at my Ko-fi page. That's ko-fi.com/physicsrocks. For notes, quizzes, and syllabus updates, check out my website at physicsrocks.com. Do subscribe to my YouTube channel for more free physics lessons from your physics teacher, Miss Hu. Happy studying and all the best!